All right, we are going to review the last two questions that you just answered relating to states of matter and the arrangement of molecules in those states. So in which state of matter do particles move fastest and with little effect on each other? Think about what you put as an answer. You don't have to retype it, but just say it out loud. Awesome. It's a gas. And then we can go ahead and draw a model of our gas. So if we have here we go, we'll draw a shape. And we're going to put the molecules all around. And we also need to make sure to include those arrows to show those movements of the molecules in the space. I want us to think about why. Why, in the state of a gas, do the particles move the fastest and have little effect on each other? Because gases don't have a definite shape and size. They take up the space of the area that they're in. So if you think about water vapor is all the molecules are so spread out and they move really fast around each other. So now let's think about the next question that you had about modeling the arrangement of molecules in an ice cube. What state of matter is an ice cube? A solid, a liquid, or a gas? Awesome. An ice cube is a solid. Now, how are those molecules arranged in that solid ice cube? Great, they're tightly packed together. Why are molecules like that in solids? Great, because solids have a definite shape and size, and that's what makes those molecules so tight together. Now, we talked about this a couple weeks ago. Are the molecules just still? No, they're vibrating, right? Those molecules are vibrating against each other. They're tightly packed, but they still are really eager to kind of move. So how do we model those vibrations of the molecules? Great, with those so if this is my molecule in a solid, you want to put those two little lines to show the movement of those molecules. Now let's take a moment to reflect. Maybe you made a mistake along the way based on what we just talked about together. Go ahead and reflect on those mistakes if you did make one.